Hi, I'm Rohan and we are from Team Tuesday 23 and our project is IoT based biogas plant health monitoring. We have Jujhaar and Sankalp as well. So about our project, we have a system for monitoring CO2 levels and humidity levels in a biogas plant, and the sensor readings are continuously published on a web server which can be visualized with vivid plots as shown in the screen. We also have a buzzer alert system. We also have a modular design so that gas sensors can be easily incorporated in the future.
So our proposed approach is encapsulated by this block diagram, where we have our main ESP32 microcontroller, which is powered by a USB connection, where we also have a USB to UART bridge for communication with it. It is Wi-Fi enabled, and thus we can access the cloud and our server through any Wi-Fi access point. Finally, we have an alarm buzzer, which of course rings if some certain threshold is crossed. And finally, we have the I2C bus where the sensors are attached and the LCD is also attached.
Our solution is based on the ESP32 chip, which is mounted on our custom in-house designed standalone PCB. We are using pre-calibrated sensors for providing accurate measurements without the need for tuning them. We also have cloud connectivity via a Wi-Fi interface on board. Our software stack is based on the Expressive IoT development framework, which is based on embedded C. We further have a live LCD monitor for displaying the readings of the sensor. Along with this, we have a server for continuously monitoring and logging the data. And finally, we have a buzzard alert system which triggers whenever the CO2 readings exceed a certain level. Over here, you can see our system. This is our custom in-house PCB with the ESP32 module mounted on top and the onboard buzzer. On the left, you can see our two sensors, the CO2 sensor and the humidity sensor. And on top, we have our LCD module. And finally, we have our external programmer and power supply module.
So these are some of the issues that we faced throughout the project and how we solved them. For example, we had a problem with insufficient power supply from the USB port, which is on our laptops. This is because it can only provide some certain amount of current. We solved this by using USB power bricks of higher capacity, so that they were able to power the system with sufficient current. Next, we had an unreliability with the USB to UART bridge IC on our system, which was very unreliable and it malfunctioned randomly. We fixed this by using an external USB to UART, programming interface. Finally, we noticed a poor quality with the PCB lab PCBs, and we were not able to make our project work with that completely properly. And that's why we went for a PCB power PCB finally.
Have the video demonstration.
So in our video, we are basically demonstrating this is the startup screen. The system has started now. You can see the value of CO2 and the humidity displaying on it. That is a nozzle from where the biogas, is connected. This is the server, and now we'll notice that as the nozzle is opened, um, the readings of CO2 increase, as you can see on the graph, as well as on the LCD. Yeah, increase on the graph. So this is after the nozzle had been closed. So as you would expect, the CO2 values were gradually dropping. And of course, since they are plotted on the graph, you can see a visual representation of the same. Lastly, we have our buzzer testing. Um, I blew into the CO2 sensor such that the value of CO2 increased past the threshold, so that we can hear the buzzer.
Yeah, so you can look, you can have a look at the plot of it increasing, and as it will cross 3000, so yeah, it just crossed 3000 there.
So yeah,
So
that
that
concludes our
was
uh, video demonstration.
So we are able to provide a live display of the sensor readings on our LCD. We got the real-time plots of our sensors on the dashboard. Our CO2 readings were quite accurate, in fact matched the ambient concentrations of the CO2. Further, the triggering of the buzzer was successful whenever the CO2 concentration crossed a certain threshold.
Thank you.